Hello, in this video we're going to look at transformations in matrix form. And this is for learning intention 40. Can you believe it? We're up to learning intention 40. This is going to be part 1. So I want to do an informal treatment just to get you getting a feel for this, and so you can realize it's actually not that scary, because I think matrices can be a little intimidating. So I want to convince you in this video it's not that scary, and once you're convinced it's not that scary, in part 2 we'll do some trickier examples. So this video we're going to start with definitions and examples. So let's start with the point and we're going to define these as, these are called column vectors, x, y. So it's another way of saying a coordinate. It's another way of saying x comma y. Another way to say it is as this column vector or column matrix. So let's define it as 1 comma 1, or just 1 1. So we have this point 1 1, and just do a nice little neat graph, and let's plot this point, and we're going to do a bunch of things to this point. Okay, so there's 1 comma 1. What can we do to this point? How can we manipulate this point with matrices? Well, let's start with one. Let's start with doing something like this. Let's multiply by the identity matrix. This is the identity matrix. This is the number 1 of the matrix world. It's the multiplicative identity. Let's multiply 1 comma 1 by the matrix identity. And just to remind you how to multiply matrices, I'm going to do this the long way. Now, if you don't remember, get out your Year 11 textbook. Remember how to multiply matrices, very important. So we do 1 times 1 here, 1 times 1 plus 0 times 1, 0 times 1 plus 1 times 1, 1 times 1 is 1, plus 0 times 1, so that's just 1, and that's just 1 as well, 1 1. So multiplying by the identity matrix, the point ends up in exactly the same place as you would expect. It's the identity matrix, it's the multiplicative identity. 7 times 1 is 7, so it doesn't change anything, just like the identity matrix doesn't change anything here. So let's spice things up a bit. Let's try a different sort of matrix here. Let's try 3, 1 in a diagonal times 1 comma 1. Please make sure you know how to do this by hand. When you multiply this out, you'll end up getting 3 1. Practice that by hand. Please make sure you know how to do that. Let's put this on our Cartesian coordinates. 3 1. Well, this is the x value, 3, and the y value is 1. Something's changed here now. Aha, it's dilated. You can see the dilation there. Look at it get stretched out. It's dilated from the y-axis, so it's moving away from the y-axis by a factor of 3. So it's dilated by a factor of 3 from the y-axis. So we can see modifying this value is a dilation. So this is a dilation by a factor of 3 from the y-axis. Alright, that's all well and good. What's next? You can probably guess I'm going to modify this point down here. Let's see what happens. 1, 3, 0, 0. Let's do the matrix multiplication, and when you multiply that out you get 1, 3. Let's plot this on the Cartesian coordinates. X is 1, y is 3, it's up here. See what's happened? So the original point was here, it's 1, 1, and it's stretched out up here. It's stretched up to here. And that's away from the x-axis. Aha, so this must be dilation by a factor of 3 from the x-axis. So this is dilation by a factor of 3 from the x-axis. Notice the subtle differences with DRT. Make sure you notice that. Alright, well, that's our dilations. What about reflections? Reflections are important as well. I'm going to multiply by -1, 1, 0, 0. Multiply our point, so that gives us -1, 1. Alright, where does that sit on our Cartesian coordinates? So we started with 1, 1, now we're at -1, 1. What's that a reflection in? We started there, we're now over there. That's a reflection in the y-axis, so the y-axis is acting like a mirror. Reflection in the y-axis. Alright, what's next? What's going to happen when I make the bottom one negative? If that's a reflection in the y-axis, what's going to happen next? That's a reflection in the y-axis, so predict what's going to happen when I multiply by this matrix. We're going to get that equals 1, -1. Let's plot that. 1, -1. Yep, that's a reflection. You can see the original point was there. That's a reflection in the x-axis. A reflection. Whoops, I don't know why I changed to black. A reflection in the x-axis. Great. Dilations, reflections. What about translations? I'm going to clear this in 3, 2, 1, gone. What about translations? Well, that's where it gets a bit different. You have to add a column vector. So if you've got 1, 1, and let's just plot it over here again for reference. So there's 1, 1, and you have to add a matrix. So let's add 3, 0. So what does that give us? 1 plus 3 gives us 4. 1 plus 0 gives us 1. So that takes us to 4, 1, which is over here. Aha, we have translation. It's translated to the right. By how many units? 3 units. So this is translated 3 units to the right. Notice how I'm talking about units here. So dilation is about stretching by multiples. It's multiplicative. Translations are about adding and subtracting. So you're moving a certain unit. Very important. And you can guess what the other one's going to do. So let's go 1, 1 plus 0, 3 gives us 1, 4. Let's put that on our graph. So let's see, 1, 4. Oh, okay, that's gone 3 units up. So that's a translation of 3 units up. Now we can stick it all together. Let's glue this all together. So this is the formal way to say all this. So a transformation on the point xy gives us the image, which is what happens after the transformation. So this is the image of the transformation. This is the image of the transformation. X prime, y prime, or x dash, y dash. So it's saying do some transformation on the point, you get some new point. And it's defined by a matrix here. If you're wondering where this is used massively in computer vision. This is a very important field. So do you know when you take a panoramic photo and there's an algorithm that stitches it together? This is the sort of maths that's involved in that. Very cool, very interesting maths. So we have a 2 by 2 matrix on the point xy. There we are. So let's see. So we've defined everything here. So we have in the top left, this is a dilation. So if you're unsure, if you're stuck, do a quick calculation. So let's pretend I'm not sure what this dilation is, or I'm not even sure if it's a dilation. Start with 1, 1 and do the calculation again. Start with the 1, 1, do the calculation, and you end up at 3, 1, and then put where 3, 1 is. And go, aha, okay, so that's the image of the point, and it's dilated by a factor of 3 from the y-axis. So we know that A is a dilation by a factor of A from the y-axis. If you're unsure about B, do the calculation, or just remember it must be from the x-axis. So B is a dilation by a factor of B from the x-axis. Great. What if A is negative? Well, now I'm stuck. I forgot what happened. What happens when A is negative? Do the calculation. Do a quick calculation. What happens? Try it out. Have a play. No harm in having a play. So you get negative 1, 1. So that's the image becomes over here. So you get negative 1, 1. And you go, aha, that's a reflection in the y-axis. So if A is negative, we have a reflection in the y-axis. And if B is negative, we have a reflection in the x-axis. Alright, well, what about these? I forgot what C does. I know it's a translation, but I'm not sure what it does. Let's look back up here. We're adding 3, 0, and we've translated 3 units right. Okay, so C is a translation of 3 units to the right, or C units to the right. So, so if it's a positive C, it's a translation to the right. Negative C is a translation to the left. Oh, and I've forgotten what D does. So let's look back up here. What does D do? Alright, it's going up by 3 units. So it must be up and down. So positive D is a translation up. Negative D is a translation down. So you should be able to go from first principles. You should be able to learn, go back and learn matrix multiplication. This is what you need to do. Go back and learn matrix multiplication. Remember how to do it. And see if after watching this video, you can come up with all these facts by yourself. See if you can follow that exact same process. So take the notes down. You got the notes down. Good. Try to do this all again by yourself without the notes, by doing all these transformations. And if you have been, thanks for watching.